All right, packet lesson 4-3 can be found on page 135. So here's a bunch of sample problems. Now, we've already done the pre-lesson, so I'm going to skip a little bit of this up here. But I'm not going to skip this. Notice this is a difference of two perfect squares. What did I say? Make a set of parentheses, make one plus, make one minus. Now what's the square root of 16x squared? 4x. Those go in the front. What's the square root of 25? 5. Those go in the back. Done. Very simple. Now, these right here are little kind of formulas, but we're going to skip over this. I think it's not going to be too necessary. These are supposed to be little warm-ups as well, but I've already covered these in the pre-lesson, so we're going to dive right into these sample problems. Now, student number 1 comes along and says, hey, I'm just going to treat this like it's a Gauda one. You know what? That's a good idea because these numbers are not very big. So there's a Z, there's a Z. By the way, get in the habit of making these little lines in your Z's. If you're going to go a long ways in math, you don't want to mistake a Z for a 2 or a 2 for a Z. And because this is a 1, I can go right to here and say, hey, what are 2 factors of 9 that add up to 6? So that'd be 3 and 3. And see, now I got 3 and 3. I could leave that as my answer, but because this is the same thing as this, I can write my answer like that. And that's what this is trying to tell you right here, okay? I just let the problem kind of explain it itself. All right, in the pre-lesson, I alluded to example 2 being a nightmare if you let it be, because some student might go, oh, I'm going to multiply this by this and get some huge number and figure out 2 factors that up to negative 66. No way. You say a little prayer. Say a little prayer. See? Praying hands. And you say, all right, I'm going to take a shot at this because I can see this is a perfect square root and I can see this is a perfect square root. I do want you to notice, though, this is negative, which is going to be significant. But what we're going to try to do is we're going to say, okay, all right, what's the square root of 121? 11. What's the square root of s squared? S. We're going to try putting those in the front. Now, what's the square root of 9t squared? 3t and 3t. Now, the question is, how can my final term be positive if the middle stuff is negative? That means they both have to be negatives. And if you wanted to take a quick peek, first, that'd be 121s squared. Outside, negative 33st. Inside, negative 33st. Gives me that, negative 66st. And the negative times the negative is positive. Then I get 9t squared. See, I did it. But because this is the same as this, Algebra 2 is going to want you to fancy pants it up a little bit and write it like that. They're both correct, but this is just a little simpler. All right, what do we have here? We have a difference of 2 squares. Just jumps out at you. Take the square root of that, take the square root of that. But you got to remember, one of them's a plus, one of them's a minus. Now what's the square root of 16k squared? 4k. And 4k. Getting a little messy, sorry. Then you put your ones there. Now can I take that little shortcut and write it like this? No, because these are different. Sorry, that's bugging me a lot. 4k plus 1, 4k minus 1. There. All right. And then out of nowhere, a really unique little problem comes. What in the world can I do with this? Is this a difference of 2 squares? No. Because there is no perfect square root of 2. It jumps right out at me. There is no perfect square root of r. There is no perfect square root of s. What can you do? Well, you can take out your greatest common factor. Well, I got a 2 and a 16. 2. I got 2 r's here and 1 r here. The most I can take out is 1 r. I've got 1 s here and 3 s's here. The most I can take out of both of them is 1 s. And now I have to ask myself, what do I put here now that I've taken this factor of 2rs out? That'd be 8r. The minus just stays. And then what would be left if I took 2rs out of this? I'd be left with just a couple of s's. And if you don't believe it, distribute it through to see if you get this back. And you will. All right. On the back side, It's called factor by grouping. Now the good news is, because I taught you nada ones already have taught you what to do. Grouping means you just insert parentheses around the first two and the last two, hoping to keep a positive in between the two, which this one's already set up for you to do. Now, there can be a twist in these problems that you don't see coming, and I'm going to show that to you. But you just follow what I've taught you prior. You're going to say, hey, what can I take out of here? A y. What's left? X plus 3. What can I take out of here? A 2. What's left? X plus 3. I take out the 1 that's in common to both terms, literally factoring it, and then I take them out. I'm left with y plus 2. Now, some of you are like, whoa, those are super easy. Yeah, they are if they work out. And that's the twist of these problems. So if I tried that right now, I got a little problem right here. I don't like that negative right there. So what I might try to do is say, hey, I'm going to rearrange some of this. 3xy minus 4. I'm going to go plus 2y minus 6x and just hope for the best. And yes, that's okay to rearrange stuff. Now I'm going to try this. Now watch what happens. What can I take out of here? Nothing, but you have to try to take something out. So I left with 3xy minus 4. Now what can I take out of here? A 2. I'd be left with y minus 3x. Every single problem up until now, we've had a match here and a match here. So I know what you're thinking. You're thinking, wait a minute, I think this is prime. Don't just hope that it's prime by writing prime down. What did I say originally? You can rearrange stuff. Now what I'm going to do is rearrange stuff that appears to be kind of paired up. Let me grab my little highlighted marker. If I paired this with this, you know, it looks like they work together. In other words, I can factor something out of those, so I'm going to pair them up. And again, hope for the best. And now I've got this guy and this guy. I'm going to write the positive one first on purpose because I want a plus in between it. It just makes my life a little easier. And now I insert my parentheses. I look for my greatest common factor, which would be 3x. I'd be left with y minus 2. What can I take out of here? A 2. What would I be left with? And look at that. By rearranging them, I actually get this thing to work. Now, will they all work? Not necessarily. But remember, these problems are handwritten by mathematicians to make you suffer a little bit and then find the gold. Okay? So yeah, some problems take a little bit more work than others. So let's try this last one. What I'm going to do is just kind of look at this and say, well, what could I pair together? Well, look at this has an x and this has an x. So I'm going to go ahead and pair those up. xy minus 3x. And then I got this negative 4y and 12, so I'll just rewrite that. And you remember how I've been saying you want to keep that thing positive? Let's try not making it positive and show you the trick we need. Well, we're going to put parentheses there. And if I put parentheses here, I'm in trouble. So I'm going to add up. And see, that's how we're going to take care of it. And now we're going to hope for the best. What can I take out of here? An x. What would be left? Y minus 3. What can I take out of here? Well, for this to work, I'm going to jump the gun a little bit and just put a y minus 3 here. That might help me understand what I need to take out of here, which would be a negative 4. If you think about it, if I distribute, I'd get this back. And see, we out-thunked it. And we get x minus 4. And we're done. All right, good luck on the assignment, guys.